Hello and welcome to Code Meraki. In this video we are going to learn how to calculate factorial in Python. Let's jump into our Jupyter notebook to see things in action. The factorial is a non-negative integer n written as n exclamation sign. If the given number is 1 or smaller than 1, then the factorial of that number will be 1. In this example we can see that factorial of 5 is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, that is 120. In this video I will be showing you 3 different ways of calculating a factorial. We will start with the most optimized one, which is using a built-in math module. If you are appearing in an interview, then go with the second one, which is an interview friendly method, in which I will be showing you how to calculate a factorial using loops. The third one is a Naïve Recursion. Python has no tail call optimization, so deep recursion risks a stack overflow. Function call overhead on every level makes it significantly slow. So recursion is practically not for the larger dataset. It's applicable only for the small dataset. Let's go ahead and start writing the functions. So for built-in function, I have to import the math library first. And then there is a method factorial inside it. So just do math.factorial. And we will pass the input, that is n here. Now I'll just go ahead and return it. Let's call this function. So these are the test cases that I have created. So we will be just passing this function inside a loop. And let's print it. Okay, we got some error. Maybe the spelling is mistake. Alright, so now you can see that actually I have not run that cell. That's why it was giving this error. Now you can see that we are getting 3 factorials. For number 5 it's 120, for number 6 it's 720, and for number 10 it's 362 8800. Now let's go ahead and write the factorial function using loops. In loop, I will be creating one variable with the name result, and I will be assigning a default value that is 1. Now I will start a loop for I in range, and this loop will start from the second value and will go all the way to n plus 1. In the end, I will just go ahead and do result multiply equals to I, and let's return the result. Let's run this cell and go ahead and call the test cases. Let's just copy paste this entire thing. And this time, instead of factorial using built-in, I will be using factorial using loop. Now you can see that I am getting the same answer here also. Now this time I have run it using a loop. Last is using a recursion. Now if you have a small dataset, you can go ahead and use recursion, but it is not applicable for the large dataset. So for recursion, first of all I have to write a base case. So our base case is, if the value of n is smaller than or equals to 1, then we should return 1. And if that is not the case, then return n multiplied by factorial. We are calling the function, and as a parameter we will pass n minus 1. Now let's go ahead and run this cell. Write a test case for this one also. So here you can see that I am getting same result, that is 120, 720, 362, 880. Now let's go ahead and try to increase the test case size. Let's make it 100 this time. Okay, for the built-in we got the results, for the loops also we got the result, and for the recursion also. Now let's go ahead and increase the dataset once again. Alright, so for the built-in it is working, for the loop also it is working. Now let's go with the recursion. For recursion also it is working. Now the question must be arising in your mind that I mentioned that this built-in one is the most optimized one, whereas this loops one is the interview friendly, whereas the recursion is the worst one. But when we are running it, they all are giving the same results quickly. So to prove that, I have written a different code over here, that where I am using a timeit function that will give me the exact time how much a function is taking or a piece of code is taking. So in this case, you can see that this math.factorial function is taking 0.366 seconds, microseconds, whereas the loop is taking 1204 seconds, and recursion is taking the maximum time out of these, which is 2051. Although it's very fast, but for the large data set, it is not efficient. Now let me go ahead and quickly give you a recap of this code. Like what I have done over here is, first of all, I have imported math so that I can use it inside the math.factorial. Then I am using a timeit function. Timeit function is used to calculate the time. So I have declared here I am giving 300 as a default value to this this thing. What I am doing over here is I am using timeit.timeIt method inside timeit library. Here I am passing the functionality that I want to do. Let's say I want to call this math.factorial and pass n. Now I have to set up. In this setup, I have to do import math and the value for n, which is 300. Next, I am doing it for the for loop. So here, same thing, just need to write result and result equals to 1. The same thing that we did over here in the code, right here. Similar thing is written here also. I am writing for I in range starting from 2 till number n plus 1. And then I am just multiplying and equals to I. Now here setup is n is equal to 300 again. So same input I have given here also 300. In the recursion also I have given 300, and in math also I have given 300. So for the same input I am getting different times here. Let me run it once again. So here you can observe that math.factorial is the most optimized way of writing this factorial function. In production, we always prefer to use a math library. But if we are doing an interview, the interviewer is curious about, do you know the functionality or do you know how to use loops? So to prove that, we have to write it using a for loop or while loop. Whereas recursion is another way. Like sometimes interviewer asks you to, can you write this using recursion? At that time you can show them. Also you can mention that recursion is not an optimized way. It's applicable only for the short data set. So in this way we have learned how to write a factorial program using Python. If this video was helpful to you, please do like the video, subscribe to my channel for more videos like this one. Thank you for watching. Have a great day.